Hello everyone, this is Vander Kolgi. I'm here today to talk about manufacturing. In today's lecture, I'm going to talk about what is manufacturing, and I'm going to take you through the materials in manufacturing and discuss about the different manufacturing processes, and also we'll finish the lecture by talking about the different production systems. But what do you think is manufacturing? So manufacturing as a verb is basically the act of making something, let's say a product, from raw materials. Manufacturing is technologically, economically, historically important. But in order to find out why manufacturing is technology important, let's define technology. So technology is the application of science to provide society and its members, like us, with those things that are needed or desired. Technology provides the products that help our society and its members to live better. So manufacturing is basically as the application of technology to produce products of increased value. So what we do in manufacturing, we're going to use technology to produce products, which of course they get a much more higher value. Manufacturing is also economically important. So if you see the graph in here, so you will see that manufacturing has 9% of our total economy in UK. And it has the 10% of the total employment and 45% of our exports. So basically, manufacturing has become one of the ways that the nation create the material wealth. So if you compare these figures with the UK, with the USA, for instance, you can see that a manufacturer has 20% of their gross net product, in comparison to the agriculture, which is 5%, and construction, which is 5% only. So manufacturing is economically important. Manufacturing is also historically important. Throughout the history, human culture that were better at making things were more successful. Making better tools meant better crafts and weapons. Better crafts allow the people to live better, and better weapons allow them to conquer the other cultures in times of the conflict. So to a significant degree, the history of civilization is basically the human's ability to make things. The evolution of the human being is aligned to the development of tools, from the stone tools to the copper tools to the mechanized and automated manufacturing facilities which we have these days. Which basically we move from made by hand to the mechanized and automated equipment that we have these days. But let's go back to define manufacturing again. So the word manufacture is derived from two Latin words, the manus, which means hand, and the factus, which means make. And once we put them together, we have made by hand, and this is what we discuss about it. Most modern manufacturing operations are accomplished by mechanized and automated equipment that is supervised by human workers. So we said manufacturing technology important. So in manufacturing, we're going to use the physical and chemical processes to modify the geometry, properties, or appearance of the block of materials or starting material we have in order to make parts or products. Manufacturing also includes assembly and almost always carried as a sequence of the operations. As you can see here, in manufacturing, we start by block of materials. I'm going to go through the manufacturing processes by using machinery, tooling, power, the labor, and at the end we get the products, or let's say the process parts. And depends on what method of manufacturing we use, we have the different scraps and waste at the end. So it's always carried as a sequence of the operations. We also said manufacturing is economically important. Manufacturing adds value to the material by changing its shape or properties, or even by combining it with other materials. And that can be done by one or more processing as well as the assembly operations. So let's say you have a starting material, a block of material as for instance, let's say a wood, and which has its own cost. And now we're gonna do some sort of the manufacturing process on it, which of course adds some sort of cost according to it, but then it adds much more value to it. So a process parts or product, let's say furniture, it costs them way more than the starting block of material that you use, which is basically wood. Industry consists of enterprises and organizations that produce or supply goods and services. Industries can be classified as primary industries, those that cultivate and exploit natural resources such as farming and mining. Secondary industries, which basically take the output of the primary industries and convert them into consumer and capital goods. Manufacturing is the principal activity here, but of course we have the other examples such as construction and electric power generation. Also, we have the tertiary industries such as service sectors like banking, for instance. Manufacturing also includes the several industries which the products are not covered in these slides, such as beverages, chemicals, and food processing. In today's lecture, whenever I use manufacturing, basically I mean the production of the hardware. They can be nuts and bolts, forging, cars, airplane, digital computers, plastic parts, and even ceramic products. The quantity of products made by a factory has an important influence on the way its people, facilities, and procedures are organized. Annual production quantities can be classified into three ranges. A low production, which basically wants the company manufacture 1 to 100 units annually. Medium production, whenever we have between 100 or to 10,000 units manually which has been manufactured. Or also the high production, whenever we have over 10,000 up to the millions of the product that has been manufactured in a year, we call them the high production. Product variety refers to different product types or models which has been produced in the plant. Different products have different features, they are intended for different markets, and some have more parts than others. When the number of product types made in the factory is high, that indicates a high product variety. Product variety and production quantity has the reverse relation with each other. So for instance, whenever you have a low product variety, you can have the high production quantity. And also whenever you have a high product variety, you can go with the low production quantity. And that's generally what it means, that basically, let's say you have a couple of products, and then in that case, you can go with the mass productions for 10,000s up to the millions of that product. However, if you're manufacturing different type of products, different varieties, then you have a low production annually. We have two type of product variety. A soft product variety, one is basically there is a small difference between the products. As an example, let's say between the car models made on the same production line, which they have many common parts among models. And on the other hand, we have the hard product variety, which basically product differs substantially. As an example, let's say you are manufacturing a car, a different type of cars, let's say like Volvo, and there is a substantial difference between a small car and a large truck with few common parts, even if it actually exists. When we discuss manufacturing, we discuss about the manufacturing capability. A manufacturing plant consists of the processes and its systems, including the human resource and people, which they are designed to transform a certain limited range of materials into products of increased value. The three building blocks, material, processes, and systems are the subject of the modern manufacturing. Manufacturing capability includes technological processing capability, the physical product limitations, and production capacity, which we're going to discuss in next few slides. Technological processing capability is basically the available set of manufacturing processes in the plant or in the company. Certain manufacturing processes are suited to certain materials. As an example, by specializing in certain processes, the plant is also specializing in the certain materials as well. This includes not only the physical processes, but also the expertise of the plant personnel. As an example, for instance, a machine shop cannot roll steel, even a steel mill cannot build cars. Physical product limitations, it basically the limitation on the size and weights on the parts or product that can be made in the plant. Product size and weight will impact the production equipment and material handling equipment as well. Production capacity or plant capacity is defined as the maximum quantity that a plant can produce in a given time period under assumed operation condition. Operation condition refer to the number of shifts per week, hours per shift, and direct labor. And capacity is measured in terms of the output units, such as tons of steel or number of cars produced by the plant. As an example, let's say a BMW factory in Munich produces 1,000 BMW cars per day, versus Reuters plant in Goodwood makes only 10 to 15 cars per day. Let's discuss about the materials in manufacturing. Most engineering materials can be classified into one of the three basic categories: metals, ceramics, and polymers. The chemistries and also the mechanical and physical properties of these materials are different. These differences affect the manufacturing processes that can be used to produce products from them. Metals are usually alloys, which are composed of two or more elements. At least one of them is metallic. And they consist of the two basic groups. The first metals, which they are based on iron, such as steel and cast iron, and non-ferrous metals, which covers all other metallic elements and their alloys, such as aluminum, copper, magnesium, and so on. Ceramics are compounds containing metallic, semi-metallic, and non-metallic elements. Typical non-metallic elements are oxygen, nitrogen, and carbon. For processing, ceramics divide into two categories: the crystalline ceramics and glasses. Crystalline ceramics, they are much more stronger than glasses. However, glasses, they are transparent. Polymers are compound form of repeating structure unit called mers or monomers, whose atoms share electrons to form very large molecules. Polymers can be divided into three categories: thermoplastic polymers, which they can be subjected to multiple heating and cooling cycles without altering molecular structure. We can melt them, mold them, and recycle them. As an example, for instance, is the plastic bottles. However, the thermosetting polymers, the molecules chemically transform into rigid structures and we cannot reheat them. So let's say plastic frame for the sockets that we have in the UK. And on the other hand, we have the elastomers, which show the significant elastic behavior like the tires of the cars. Also, we have the composites. The composites, they are non-homogeneous mixture of the other three basic types rather than they have their own unique category. For instance, whenever we have a mixture of the metals and ceramics, we will be able to create the metal ceramic composites. Whenever we combine the metals and polymers, we can have the metal polymer composites. And also whenever we combine the ceramics and polymers, we can have the ceramic and polymer composites. So whenever we actually make the composite, we want to maintain the average property of the main materials such as metals, ceramics, and polymers. Now let's talk about the manufacturing processes. We can categorize manufacturing process into two different categories. The processing operations, which in here we're going to transform a work material from one state of completion to a more advanced state. And basically in here, operation means the change of the geometry, properties, or appearance of the block of material. And also we have the assembly operations, wherein in here we're going to join two or more components to create a new entity. So as you can see here, the manufacturing process is divided into the two groups: the processing operations and assembly operations. In the processing operation, we have the shaping processes, the property enhancing processes, and surfacing process operations. Shaping processes, it consists of the four different processes: the solidification, particulating, deformation, and material removal. However, property enhanced processes goes to the heat treatment, and surface processing operations is basically consists of the cleaning and surface treatments, coating, and deposition processes. The assembly operations is consists of the permanent joining processes and also the mechanical fastening. The permanent joining processes is consists of the welding processes, brazing and soldering, adhesive bonding, and also the mechanical fastening is whenever we have the threaded fasteners and permanent fastening methods. But let's discuss about each of them individually. Processing operations is whenever we alter a material shape, physical properties, or appearance in order to add value. Three categories of the processing operations are shaping operation, which we alter the geometry of a starting work material; property enhancing operations, which we improve physical properties without the changing its shape; and surface processing operations, which we clean, treat, coat, or deposit materials on the exterior surface of the work. Shaping processes are consist of the four categories: a solidification process, which the starting material or block of material is a heated liquid or semi-fluid; a particulate processing, when a starting material is consist of the powders; deformation processes, which the starting material is a ductile solid, commonly metal; a material removal process, which the block of material or starting material is a ductile or brittle solid. In solidification process, the starting material is heated sufficiently to transform into a liquid or highly placid state. As an example of this solidification process, metal casting or plastic molding, which basically the molten metal are going to be poured into the cavity area that actually is surrounded by the mold, or in this case is a sand. And once actually it's been cooled, we're going to get rid of the sprue and runner, and we're going to trim them, and we're going to end up by having the solid casting. Something like what you will see here. Particulate processing is when the starting materials are powders of metal or ceramics. Usually they involve pressing and sintering, which the powders are first compressed and then heated to bond the individual particles. The heating is below its melting point of the material. That is just enough to adhere the materials to each other. So as you can see here, for instance, you will see that basically you have the block of material as just in the form of the powders. We're going to force them together. We're going to import the force and compress them. And now that's also the product that we get as a result of it. Like what you will see in here. Into the deformation process, the starting work part is shaped by application of forces that exceed the yield strength of the material, such as forging and extrusion. So as you can see here, basically, for instance, into the forging, that we have the dies, and by the force that we get from up to these dies that actually pass the yield strength of the material, the block of material we have, it become to deform and get the shape of the dies, and of course at the end the flash will be trimmed. Something like what you will see here into the photo. So as you can see here, the forces that we get from these dies, they're gonna change the shape and deform the block of material that we have. In material removal process, the excess material will be removed from the starting piece, so what it remains is the desired geometry, is the geometry that we want. These machining processes such as turning, drilling, and milling, all of them, they are basically material removal processes. So in milling and face milling is the block of material is stationary, and the machining tool, such as the milling, for instance, they're gonna move on to remove the desired or the appropriate basically material in order to get the shape that you're looking for. The same thing for drilling. The block of material is stationary, and the tool gonna rotate, the drilling bit, they're gonna rotate and to remove the material from the bulk of material you have to get the shape that you're looking for. Into the lathe, however, is different. The tool is stationary, and basically the block of material is moving up to the time you get the shape that you're looking for. So what you will see here, that you will see that basically the CNC machine now is doing the machining operations onto the block of material that we have in order to remove the excess materials to get the shape that we are looking for. Whenever we discuss about the manufacturing processes, we talk about the tolerances. Some manufacturing processes are more accurate than others. Most machining processes, such as the CNC machining, they are quite accurate, and they are capable of tolerance of the plus and minus 0.05. However, if you compare it, for instance, with the sand casting, which are generally inaccurate. So you as a designer and your design basically would define what kind of a manufacturing process needs to be used in order to accommodate the tolerances that you as a designer designed or basically expected to have once it's been produced. Let's talk about the assembly operations. In assembly operations, we're going to join two or more separate parts to form a new entity. The assembly operations consist of the two different categories: joining processes, which we create a permanent joint such as welding, brazing, soldering, and adhesive bonding, and mechanical assembly, which we're going to use the mechanical methods to fasten two products together, such as threaded fasteners, screws, bolts, nuts, and so on. But let's talk about the production systems. Production systems consist of the group of people, equipment, and procedures used for the combination of materials and processes that constitute a firm's manufacturing operation. A manufacturing firm must have systems and procedures to efficiently accomplish its type of production. We have two categories of production system: a production facilities and manufacturing support system. Both categories include people. People make the system works. But let's talk about what are those categories. As we discussed, the production system is consisted of two groups: a production facilities and a manufacturing support system. Into the production facilities, we have the low production, which call it job shop. We have medium production, which we call it batch production and cellular manufacturing, and also the high production, quantity production and full line of production, which we're going to discuss about these into the next few slides. Into the manufacturing support systems, we have the manufacturing engineering, production planning and control, and quality control. Production facilities consist of the factory, production equipment, and material handling systems. Production facilities is basically referred to the one that touch the product. Includes the way the equipment is arranged in the factory, or what we call the plant layout. Equipment usually organized into logical groupings called manufacturing systems, such as automated production lines. But let's talk about the facilities versus product quantities. A company designs its manufacturing systems and organizes its factories to serve the particular mission of each plant. Certain type of production facilities are recognized as the most appropriate for a given type of manufacturing. If you remember, we discussed about low production, which whenever we have 1 to 100 units that produce annually. A medium production, which refers to the 100 to 10,000 units that has been manufactured annually. And high production, whenever we have over 10,000 units up to millions of products that manufacture in a year. So different facilities are required for each of the three quantity ranges. Job shop is a term used for the type of the low production facilities. A job shop makes low quantities of special and customized products. Products are typically complex, such as a space capsule, product aircrafts, special machinery, and so on. So usually into the job shops is the human workers that are gonna operate the machines. Equipment in a job shop is general purpose. The labor force, they are highly skilled, and also the job shop is designed for maximum flexibility. So we can divide the medium production in two different categories, depending on the product variety. A batch production, which is suited to the hard product variety, and setup required between the batches. So the product go to the different stations and different operation has been done on them. On the other hand, we have the cellular manufacturing, which is really quite well known these days, is suited to the soft product variety, and worker cells organized to process parts without the setups between the different part styles. High production, often referred to as mass production. Whenever we have a high demand for product, the manufacturing system is required to dedicatedly work on the production of that product. We can categorize the mass production in two different categories, the quantity production and full line production. Into the quantity production, as far as there is a mass production of a single part, either a single machine or a small number of machines will be dedicated to manufacture that specific part. It typically involves standard machines equipped with special tooling, and also equipment will be dedicated full time to the production of one part or the product type. Typical layout used in the quantity productions or the mass production are process layout and serial layout. We also have the flow line production, which basically multiple machines or workstation are arranged in a sequence. And whenever a product is complex, basically require the multiple processing and of course the assembly operation at the end. Work units are physically moved throughout the sequence to complete the product, and workstation and equipment are designed specifically for that product to maximize the efficiency. A company must organize itself to design the process and equipment, and to plan and control production, and to satisfy the product quality requirements. All of these will be accomplished by manufacturing support system, which includes the people and procedures which a company manages its production operation with. In order to have the manufacturing support systems, we need the different departments, such as manufacturing engineering, production planning and control, and quality control. Here you see the overview of production system and major topics in the fundamental of the modern manufacturing. So the time that actually the engineering materials would be shaped by different manufacturing processes and assembly process, up to the time we go to the finished product, these manufacturing systems, the support system and quality control system make sure that everything goes well into the production line. So I've put the different method of the manufacturing, which was quite spectacular in making the products, and I want you to take you within the next few minutes. That was it for today. Hopefully you learned something new about the manufacturing, different type of the manufacturing processes, the materials, and also the systems. Thank you so much. This is Svandir Kolgi. See you later.